Hi everyone. I've pre-recorded this because the day that we are supposed to talk about this is also the day that I'm having a tooth extracted. So I thought that I may not be able to do such a great job. So hence the pre-recording. So Felicity's asked me to talk to you about how you might use a saw pit and describe saw pit to your client group or the farmer groups or whatever that you work with, and hence the tips and tricks thing. But before starting, I just wanted to say that I suspect that a lot of you are better at this than you think you are, and sometimes it's just a confidence thing. And further to that, the more often you do it, the more comfortable you'll get with doing it, and maybe have lots of practices, maybe even film yourself, and excruciating as it is, watch yourself back and see if you can improve what you do or how you present things. Don't be afraid to have notes in the pit with you to remind you what you need to do, or another person to help jog your memory. And maybe if you're going to make the videos, you could share them with some of your colleagues within this group so that you get peer feedback, that sort of thing. So practice, 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 I think. So let's get started. The first question I would ask myself, and I guess it's fairly obvious, is why are you having a saw pit? What do you want to show? Because that will help you decide where to site that, whether to have more than one pit or try and get some contrast in one pit itself. So you might go from, a wheel track into a bed if you're looking at cropping things. You might have a fence line pit, you might have a disturbed site, an undisturbed site, that sort of stuff. Or you might go across the landscape and look at the soils through the landscape, or what's called a topo sequence, or used to be called a catena. And also that question will help you think about what kind of demonstrations or activities you want to focus on and get the participants to do. So I would try and get your participants to do as much, if not all, of the things that you show them as much as possible, because it's just a basic learning principle. They'll probably remember it better if they've heard it and done something to reinforce that learning. So however you want to do that, whether you have activity sheets, stations that they work through, you pull people out of the audience, that's sort of up to you, but I would really try and get people to do stuff. What you want to show and where also will govern which experts you might talk to beforehand for your own sort of edification, but also who you might like to have in the pit with you or as an expert there on the day. And what other expertise you might call upon in terms of soil mapping and things like that. And then also, obviously, what resources you'll need to carry out some of those demonstrations and things like that. So, okay, so this next slide is obviously the digging bit. And the things to ask yourself here, obviously, we're in the landscape, given the questions we've asked previously in the previous slide, and also access. That's fairly straightforward. But I guess the main reason that I've put this slide in is around just to be aware of the WH and S considerations. And obviously they're governed by federal legislation, but each state has their own little sort of legislation, and then SWIMS, state safe work methods, and all that stuff around those. And all that sort of really governs is the depth that they can be before they'll need things like shoring so they don't fall in on people, and their width, and then their access. So I think one of the main things to remember is it's less like this top photo and more like the bottom. And in the bottom we have Jason and Helen from New South Wales DPI, and that's a really great soil pit. It's nice and wide for people to get around. It has a nice sort of ramps at both ends for in and out. It's got the steep edges of the pit roped off so people can't fall in break a leg or whatever. The other important thing to mention about the depth is that usually the depth is the depth of the profile that we see here in front of Jason plus the spoil behind. So if you want your soil pit to be deeper than that, you'll have to make sure your spoil is right far back. And the other thing also to remember here is when you're having it dug, that if this is the profile here that you want to look at, the one that Jason's standing against there, don't have the digger drive across that and compact all the soil so that it's not actually how it is in its natural state. So that's good to remember, particularly for people who are digging them that are not familiar with digging a soil pit. So they're probably the main things. You might have to fill out some swims or something for them to show how you're going to manage the risks of having a soil pit. The other thing, obviously, here I've got here, don't forget to dial before you dig, so you don't have to pay a large fine to Telstra or whatever, or deal with some irate landholder because you've dug into their services or their water or whatever. So that's always good to find out first. And you don't actually have to dig a pit. That's also what I wanted to say. Like, you can use existing things that are out there, and I'll show you how to kind of do this, or I use this in the video further on in this presentation. So you can use things like road batters. Just be aware that they might be a little bit disturbed, but if you talk about that with your audience, that's okay, or other existing sort of areas of excavation like silage pits or something. In both those cases, you're going to have to do a little bit of work of cleaning up the face. So what you're actually seeing is not the weathered material of the batter or the side of the silage pit, but you dig in a bit and you can see the actual soil in profile. So it's expensive to have soil pits dug, so that's a way of trying to, I guess, maximize the number of soil profiles that you see without having to pay for a lot of money. And then there's also this idea of a soil peel or a soil monolith. So lots of areas in New South Wales have soil monolith collections, like we've got some in the North Coast. I think there's some up around Armidale. Tokal College down in the Hunter has a collection, so it's worth finding out where they exist. Or you can make your own soil peel, which essentially just spraying a whole lot of latex onto a soil profile and then peeling it off, and you can keep that for later. So that can be a really good resource to create. It's a bit time consuming and a bit fiddly, but if you are interested in how to do that, Tim Overhew from Western Australia has written a farm note on it, so that's worth having a look at. And I say it's just a bit laborious and time consuming. The other thing, I guess, that's important to mention here, which I did sort of touch on with those existing access to profiles, is to pick the face back. And I don't know if you can see here, but in front of Jason, it looks like there's a little bit that's sort of caved in the back. That's because he's been having a bit of a go at it to show what the soil profile looks like without the smearing that's happened from whatever device cut that soil pit. And another thing too is you can use a post hole digger. It's a bit of work, so you dig the post hole and then you come back and take the soil out at an angle to where you've dug the bottom of the post hole, so you can see the soil in profile. Obviously you can see much less, but if you have space and money considerations, that's something that you might think about doing. So that's all I just wanted to impress upon you with that slide. Next thing to think about is what kind of accoutrements, tools you need to have in your soil pit. So I quite like this picture because it has a slightly different way of presenting the soil pit. It doesn't have the rope around the outside, which it should, but I think it's from the States. But it kind of outlines how you might have a walk-in pit for a smaller group and the bits and pieces you need. So To start off with, there's your spade. Now, no, that's not a spade, it's a soil corer, but it's a good idea to have a spade. You might also like to have a soil corer of this sort or this sort to explain to people the different ways you can take soil samples. A tape measure is always really, really important because it has the big numbers down the side, and you can talk about where, what depth most of the roots sit at, or you can, as this person has, outline where the layers of the horizons are with this fluorescent paint, which is great, and equate them to depths, which is fantastic. Also, your field pH kit and water bottle. So that's your water bottle for your texture, and the universal indicator and the white powder to be able to see that for your pH is also really handy. You might, or you should have something like a screwdriver, a palette knife, or in this case they have a geopick to take to the face and cut back where the digger has smeared. And they haven't done this all the way to the bottom, and you can see, because you can see the digger marks. And you take that all back so that you can really see what the fabric of the soil looks like without all that smearing. Another good thing to have is small white plastic plate bowls, really, and white because it's easy to see, and that's really good for your pH measures, but also your slaking and dispersion tests later on, which we'll talk about. So they are really good bits of kit to have. You may also like a weak acid. So if you think that you might have some free lime and you want to test that because the acid will fizz, then a weak acid. A tarpaulin to put extra bits and pieces. So you might have gathered some soil from somewhere a bit further away from this soil pit, and you can put that on a tarpaulin, or some plants with their roots so you can see how long the roots are, all that sort of thing that's useful to have. A wire penetrometer and a quadrat. Now there's some homemade versions of those that you can have that are shown in the Northern Rivers Soil Health Card, which I'm sure you're all familiar with, which are really handy. The wire penetrometer you can use to poke in the side at the profile to show how difficult or not it is through the different horizons or layers, and talk about that and what that means for how biology and roots move through the profile. The quadrant is good because you can walk away from the soil pit and do things like obviously present ground cover, but also throw it around and count the different organisms or evidence of organisms within that quadrat to talk about soil biology. Jars is there for those people who don't want to get their hands dirty when they're doing a texture, so you could do a pre-set of this and have a soil sample from different layers in the profile and shake it up and then leave it overnight, and it'll separate into its sand, silt and clay layers, and show people how you can use that to determine soil texture. And then water, obviously, for washing up your hands. The other thing I'd like to draw your attention to in this pit, which is kind of cool, is that, I don't know if you noticed, but they've benched out here according to the layers that they've set for these top couple of horizons. So, and in each of those benched areas, they're taking some samples. So they've got a corer, they've taken a core, maybe they're looking at things like structure and structural stability with a bit of slaking dispersion test. They'll possibly do a pH, that sort of thing. So you can do that sort of thing. They could also do an infiltration if you had a little infiltration ring, and then you could cut back further and see where the water has infiltrated into profile. So that's really good. And then the other thing are these cards, which obviously show something or say something about the soil and profile that they want the participants to look at or be noting. So that's also a really good idea. You don't have to have the stands like this. You can actually just pin them up in the soil pit. I've done that. You can just print off the page, put a punch hole in it and then use a nail to hang it in the soil pit face to draw people's attention. That's a really good way of drawing people's attention to smaller things like evidence of biology or some different changes in colour that aren't so apparent. So that is the kit. Now, what to look at? So many things, and this very long list is essentially taken from a book, this book. Check out this one, which I think is a really useful guide if you're feeling like you're not very confident, you'll forget things. It's written from a soil survey point of view, so you don't have to do all of it because it's obviously the aim of that is to key out the soil as a soil type, but it has some really good pointers about what to do and how to carry out some of those tests. So that's a good reference. But if we start off at the beginning, we want to talk about the soil and why it is how it is, and partly that is where it is in the landscape and its geological history. And I think this is a good place to start because a lot of people are really interested in this part of their soil, like why is my soil the way it is? And you can talk about, so this point here, point 1, relates to this block diagram, and sort of rules of thumb are things like, it doesn't always work as in rules of thumb, but generally things like the soils in the top of the landscape on the tops of hills are often shallower and stonier. What does that mean for how you might manage them or how plants can grow in them? As you go down the landscape, the topsoil might get deeper and it's the parent material is further away. You can have disturbed landscapes where you have river floodplains where the river has moved across the floodplain over the eons, and you can get quite different soil types in close proximity. Or you could have, like we have up here on the North Coast, basalt flows, which have covered old landscapes and then had soil form on top of them again. Or you have right in the bottoms of valleys where the alluvial material from the hills above have been deposited. So here we get parent material that's not rock itself, but old alluvial material that the soil is formed on. So it's just about talking about that and getting that information from maybe the soil surveys in your area or older publications. Now the rest I will talk about, because what I did is I actually found a profile near my home and did a little bit of to camera as I talked about, and so we might look at that now. I thought I could talk about describing a soil profile, and then I thought the council's ripping up the road just below my house. It would be a good opportunity to look at something directly and show you. So if we have a look, first of all, this is the cutting that already existed and they've just exposed the face. So one of the first things you do in your soil pit is make sure there's a nice clean face to look at. So they've kindly done that for us to some extent. And then the other thing I suggested was to look at the soil profile in terms of its context in the landscape. So if we pan around here, we can see it's sort of hilly, and and we're on the slope that faces roughly west, which is why we get the nice sun on that that cutting right now, which gives it which is really great for it to be able to see it and photograph it, because it can be hard to take soil photographs. And I know, because I know where I am, I'm in Lismore, and I've also had a look at some of the accompanying information and soil mapping on eSpade, and having spoken to the soil
surveyor, Dave Miranda, and also looked at what New South Wales produces, these soil landscape maps, that this is a transition area between the red ferrosols that are really common towards the coast here and on the Alstonville Plateau, and people will be familiar with those, and the darker, more chocolate soils as we get away from the coast and there's a rainfall gradient. So these are formed on the same parent material, but they've had less weathering, therefore they don't have that highly red colour, but they'd still be ferrosols, or in the old classifications they may have been called a chocolate sol or a prairie sol. And then down on the flats, which you can't see down here, but it's down that road a bit more, we have the alluvial materials that form the cracking clays, vertisols, that are often cropped in this area. So that's what we can tell from the area around. So first off, the most obvious thing to ask people, and it's always really great to get people involved as much as possible. Now I'm right down the bottom, so it's a bit hard to see, so sorry, but if you ask people what they see, most obviously the things that come up are colour. So you can talk about the colour there and how obviously it's darker at the top owing to the organic matter. And if we're a bit closer, there's a car coming, so I'm going to have to pause. So as I was saying, the colour, the organic matter, and you could choose then to talk about what the organic matter may indicate about the soil, or the important role that organic matter plays in things like water holding capacity, water movement and cation exchange capacity. You could mention it then and then come back to it again later when you talk about things like structure. So the other thing to note is that the colours get lighter and brighter as they go down the profile, and obviously that's because the influence of organic matter is reduced. And in these soils, because we've had a look at the soil map, we know that they're often shallow and stony, as you can see. So it doesn't take, the profile's not very deep before it hits the parent material, and in this case it's a basalt that's jointed, so it was probably a basalt flow, and the soil's formed on top of that over time. Now, one of the things I mentioned about having in your soil kit is a tape measure. It would be really great to have a tape measure from the top there all the way down. I've given away all my tape measures because I don't do this work very much. But it would be good to have that, and to maybe have some thing poking in where you think the horizons might be.
Okay, so just to recap before we get into the more detailed and close-up section, we've looked at the position of the soil in the landscape, how that relates to what you see in the profile, and some stuff that you might find to help you to find that are the things I said in the video, some things like soil landscape maps or mapping online. Those soil landscape maps are really handy too, because they're soil landscape maps, so there's the soil and the landscape, they have great little topo sequence drawings in them, so it'll show you how the soil types in terms of classification vary across the landscape, so that's pretty handy. As I said, you use your total soil depth in terms of what that means for plants and their roots and the water in the soil. Trying to identify your parent material and what that means for the soil. So, you know, we've got basalt flows high in iron, relatively new soils in the scheme of things for Australia and things like that, look for evidence of animal and plant activity at depth. So sometimes you see, lots and lots of root activity and biological activity at the surface. Further down, you might be less so, but you could outline what that might be for, longer roots to guard against moisture stress in dry times, or hibernating of worms, that sort of stuff. And a really good piece of kit for that, as I mentioned, is the measuring tape. And also it's a good time to point out any natural man-made impediments. Basically what I mean is a plough pan, something like that. Talk about what the colours may indicate. So obviously, as I mentioned in the video, organic matter staining makes them dark. The bright red colours is an indication of iron. Lighter colours would be heavily weathered material. You often get those in between horizons where one texture is a lot more clay or denser than the other, because water sits along that horizon boundary and often flows laterally underneath, and so you get a bleaching of that material. If you really wanted to key it out, you could use a Munsell colour book, but I don't know that that's really necessary for anyone other than soil surveyors, but that's a resource you could use. And again, you can identify those horizons by colour and or texture. Usually it's texture throughout the soil. I'll get onto that in a minute. Relate all that to how that soil might hold nutrients or not. Sand probably wouldn't much. Then in that kind of a soil, organic matter is more important. Clay might hold lots of nutrients. Heavy clays, depending on the clay type, can hold lots of nutrients, but that might impact water movement. All those sorts of things to build up a picture of how your soil behaves. And again, the important bits and pieces for that part of the soil pit would be the tape measure, your texture chart or texture key, which is in the yellow book, which I will talk about in a minute, and things like your soil structural stability test or the modified Emerson aggregate stability test, and even a bit of a dispersion test if you think that that's going to be an issue with sodic soils. And you could even do a water infiltration demonstration, which I will discuss in the next little bit of video. Okay, so here we are, a bit further down the slope. Not as great profile, unfortunately. Here's my somewhat dodgy tape. I don't have a nice big one with the big numbers, but I would recommend that if you're going to do this more often, that you get one of those, because they're really handy. People can see the distance, the different layers. So we talked up there about obvious things like colour and how that might be helped to determine where the horizons. You could then also follow that on with a texture, so you could do textures at various levels down the profile. I won't do that because there's lots of information on the internet about how to do that. And also you could use the yellow book, so-called, obvious reasons, which has a key in it for determining soil texture and also soil structure. So get a hold of one of those, they're very useful, as well as some other things. And then you could talk about the importance of texture for things like water holding capacity and cation exchange capacity, and then go on to structure and explain the difference between the two. A lot of people, less so now, but used to use those two interchangeably, and obviously they're not the same thing. So the texture is a given. It's a really good thing to encourage people to do and get proficient at, so that they can go and do it on their own properties, won't change, and then they have that sort of baseline soil texture mapping, if you like, for their property, which they can use for management, hopefully. But the structure they can alter, obviously, through their management. So you could talk, again, using the yellow book, about structural things like the size and shape of PEDs and how you get large ones and you can break them into smaller bits. So that's your basic PED size, is the smallest ones you can break them into. And in the video I've included for you by Ray Wheel,
he talks about this. So then, and you could talk about how organic matter plays a role in that structure. So as you can see, hopefully on the video, the top part has, better structure, or different structure, if you like, from the one below, where there's lesser influence of organic matter, more influence from the parent material. And as I said, our parent material here is really close. So the other thing to mention, obviously that's really obvious, hopefully quite obvious when you first open a pit and talk to people and ask them what they see, is the rooting depth. Now, as we said before, this profile is really shallow, so there's some parent material here. And so even though it supports quite large plants like trees, they're obviously dependent on that really top section where all that organic matter is, all that organic life is. There's some ants there I can see, and so you would point that out. And the importance of that is both for the amount of soil that the plants have access to in terms of nutrients, but also water, so particularly in times of water stress. So if you don't have a deep profile, obviously with lots of water holding capacity, then that soil's more prone to drying out and the plants will be at risk of water stress. The other thing to look out here, which I've just noticed, which is great, is that because this is the parent material, obviously it's weathering rock like this, it's more impervious, so you can sort of see where the water comes down through the profile and hits that and sits and is quite moist there, and also a bit grey. So at different times there would be water logging here when the water infiltrates and then hits a more impervious layer and can't go any further for some time, or moves laterally like this. And this is why we get this coloration here. So you would talk about that. You would talk about how sometimes these colours are inherited from the parent material, and certainly the basaltic material that this is from has lots of iron in it, but also because of this imperviousness, sometimes you have periods where this is waterlogged and has low oxygen, and you get these greeny grey colours, and then when it dries out and the iron is then oxidised, it goes a bit orangey red, like rust. And when you get further to the coast and we have the red ferrosols, there's more of that, and you get those really amazing deep red profiles. And you can show people that, so you can break that open. Sometimes there might be roots in there, and you could possibly see if some of them have been died because of waterlogging. Sometimes it's not that clear, but in some of the root channels you'll see the red from the oxidization. And this is also a good way to check and see if you can see wormholes. So you may not see biology, but you can see evidence of it. So things like wormholes, eggs, that sort of tunneling, burrowing, roots going down old wormholes full with worm castings. And going back to the soil structure, you could choose to look at the structural stability of those. So that's your test with, I advocate the white bowls, which I don't have here, but you can choose to put different PEDs from different levels in the profile and leave them for a bit and see what happens, and explain slaking, and again differentiate it from dispersion. And you would talk about the role of the soil chemistry in that, but also the important role of organic matter in maintaining soil structural stability. So you could do that. And then obviously there's the ones that people are most familiar with, the tests, things like the pH test. again, I won't do that because I think most of you would be aware of that. You could do that down the profile, and you could choose different increments, particularly if you're in areas where there's issues about the stratification of nutrients and pH. That would be really good to show. So instead of just doing the top 10 centimetres, you might divide the top 10 centimetres up into small increments and show the difference in pH using the kit, and then talk about what that means for management and access to nutrients and things like that for the roots. What else? I haven't set it up, but here's the infiltration ring stuff, which I think I mentioned in the PowerPoint. So these are the ones that are part of the Northern Rivers Soil Health Card, which you can look at online if you haven't already. Now you could set this up on the top back a bit and fill it with water, or you could set a larger one up days before, and then you just cut a bit out there and show what's happened with the water. And it might be useful in this kind of soil, given that there's this impediment, to show that if you don't have evidence of that in the profile itself. The other thing that's good to have is keys, and I don't have them on this side of which is not useful. So I have various pictures of bits of soil biology that you might use, and in the PowerPoint I've also I think put a link in there to the Australian Museum. Has a really good sort of macro soil biology one that is a really good one to have, and you can just download that from the internet if you need to know what to look at. And the other thing, I guess, to discuss while you're in the pit is any other information that you've got around that soil. So if the landholder has some past soil testing or has done some trial work of their own or something like that, then that's a really good thing to include. And it's always good to, as I said, to take a step back from the pit and look at the landscape and where what's happening away from the soil pit face on the soil surface. And you can do things like testing for your ground cover percentage, which is a good sort of indication of some sort of biological activity. You can equate it to some sort of carbon perhaps from their soil test if you have any, and there's you can make a quadrat out of a coat hanger, which is really easy to do like that. So I think that's all that I would cover in a soil pit, but then I would try to get more interaction with the participants, obviously, and get them to do all the tests that I've talked about, and give them handling sheets, and so that they can talk about it. And there's my dogs.
Okay, the second recap. So we've looked at the biology. We looked for things like worm tunnels as evidence of biology if you can't see them themselves, or ant tunnels, whatever, casts, that sort of thing. The quadrat sampling that I talked about at the very beginning, where you can count all the different kinds of organisms in a quadrat away from your soil profile. Don't forget the rhizobia, particularly if you're looking at a crop that's a leguminous crop. So get people to look at it and judge the nodulation, and point out that, you know, this is one very good and very old example of how we've harnessed soil biology to our benefit, but that unless the legumes nodulated properly and the nodules are working, that is, they're pink inside, they're not doing the job that we planted them for as legumes. So that's really important to point out. Now, the things you could have that would help out with that was that ID book I talked about in the video, which is from the Australian Museum, which has lots of the larger bugs in the soil. Hand lens, if you wanted to look to try and see some of the smaller ones. There's all sorts of sort of bug catching things that you can do with surface litter if you wanted to do that. It's a bit different to soil profile. And if you're going to do that, some alcohol to put the bugs in there to keep them so you can keep looking at them. If you wanted to collect stuff beforehand and have a laptop, although it's not so great in the field, with a little USB microscope, that's a good way of showing smaller organisms on a bigger screen. People don't have to worry about focusing microscopes, that sort of stuff. And then, of course, there's the calico strip, or I've written indie test there, but really what I mean is undie. And I'm sure you've all heard about the Soil Your Undies thing that the cotton industry's doing, or they've taken that calico strip in a slightly different vein. But that requires a little bit of pre-work on your part in terms of burying the calico strips up to 6 weeks beforehand, depending on rain, which you can then show how that's been degraded by the biology in the soil and where in the soil it happens. So you would expect there to be a lot more activity in that surface area, but there's bits of information on the internet about how to carry that out properly. Basic chemistry, we've talked about the lime and the pH, so you'll need a pH kit, some weak acid. As I mentioned, some past soil test results would be good, so you can link things like how much aluminium is present to the pH and things like that, and try to bring it all together so people see how it all works together. And the structure stuff, we talked about that. It's important to talk about the importance of organic matter and its benefits to structure, but also cation exchange capacity. And as I said, you might like to use the yellow book. There's a modified Emerson aggregate stability test. I've got some sheets for that. There's lots of stuff on the internet. And it's also really good if you want to show slaking, to have a known sample that you know will slake. So I used to use red soils from Condobolin that were very heavily cropped, and I knew that they would just disintegrate, so people could see what slaking was if you didn't have a slaking example. So that's also a good little tip, I guess. And then, of course, if you're using another soil pit, you want to bring out the differences between those, or if you've got two zones in your soil pit, to bring out the differences and what that actually means for how you're going to manage that soil, how plants grow in it, and that sort of thing. So just to recap on a lot of that, when you're talking about texture, you just mentioned that it's the clay, sand, and silt fraction. And you could talk about how people might know that. So silt is often kind of shiny when it's a bit wet and smooth, whereas clay will be quite sticky. Sand's gritty, and you can hear, if you rub it between your thumb and forefinger near your ear, you can hear the grittiness. You can do the jar test, like I said. You could also talk about the shape of those particles and why that impacts on the water movement in the soil. So sand, quite large and often rounded. So it's like if you put lots of basketballs in a box, where they touch, there's big spaces in between. Whereas the clay is like a plate or even pieces of paper. So where they stack up, there's not very big pore spaces in between. So obviously that has implications for aeration and the movement of water in soil. I think we've covered colour. That's pretty self-explanatory. Don't forget to use secondary methods for biology rather than sightings, which is why the calico strip is kind of good. And as I said, don't forget your rhizobium and the links in between with organic matter and cation exchange and water holding capacity, particularly where soils are at either end of that very sandy and very clay spectrum. Talk about pH, stratification, what that means for seedlings, root growth, and how you might add an ameliorant if you need to. The importance of structure, not just for water holding capacity and aeration, but habitat for soil organisms, and your structural stability, which is your Emerson's aggregate test. Draw out implications for that, like if a soil will collapse when it's wet, then it's sort of prone to things like hard setting and crusting. What does that mean for erosion? So perhaps greater runoff, more erosion. What does that mean for root penetration and seedling emergence? So it's harder for those things to move through that hard set dense soil, and you can also have periods of waterlogging in those sorts of soils. So that's just a recap. So as I said here, you relate all the specifics to your soil and what you notice in your pit. And here are the resources I talked about, and there's lots more, and I'm happy for people to contact me if they need any more assistance or would like other resources. So I didn't look extensively at all the different state mapping, but that's definitely there. And then there's federal mapping through ASRIS, ASRIS. If acid sulfate soils are an issue for you in New South Wales, all councils have those risk maps. There's the yellow book that I talked about, which is that Australian Soil and Land Survey Field book. There's the Northern Rivers Soil Health Card, which I'm sure you're all familiar with, and that's got some nice little videos about how to do some of the tests in it. Then there's Ray Wiles' Soil Pit Lab videos, which are for university, but they're really good, and I would suggest you watch them just to see how he presents and what you might say and things like that, because that's really handy. So, and then there's a few other there. And as I said, your peers are really good reference too. And that's it for my tips and tricks on how to present a soil profile or soils in profile.